Hello guys, welcome back to our YouTube channel. Welcome to AdMaths plus Maths. We are now going to discuss another lesson in mathematics, which is part of our algebra lessons, solving linear inequalities. And when we are solving linear inequalities, we cannot get away from these symbols: greater than, less than, greater than or equal to, and less than or equal to. Okay? Take note that these are the symbols that represents inequality. When you solve a linear inequality, you solve in a similar way like how you solve linear equations. Example, 3x plus 2 is greater than 12. To solve for the value of the x, I am going to take away first 2. When I take away first, it will result to 3x is greater than 10. And if I want to solve for x, I have to divide both sides by 3. If I divide both sides by 3, it will become x is greater than 10 over 3, or x is greater than 3 and 1/3. If you want to know more about solving linear equations, please click the card above and watch solving linear equations before continuing watching this video. Okay? Now, what's the difference between solving linear equations and solving linear inequality? When you are solving linear equations, you have to be very careful. If you are multiplying or dividing an inequality with a negative number, I repeat, you have to be very careful if you are multiplying or dividing an inequality by a negative number, because you need to reverse the inequality sign once you multiply or divide this inequality by a negative number. Example, I have here negative 2 is less than 5. You notice that negative 2 is a negative number and 5 is a positive number. If I multiply both sides by negative 1, it will give me 2 is greater than negative 5. Please observe that the symbol or the sign was reversed. Okay? Again, I repeat, if you are multiplying or dividing an inequality by a negative number, you have to reverse the inequality sign. Okay? Next thing to understand is inequality can be shown on a number line. A number line can also represent inequality like x is greater than negative 3. If I have a number line like this, I will put in negative 3. I will find where is negative 3. Negative 3 is over here. Okay. Since negative 3 is not included, I'm not going to include that in my graph. I will just put a hole on that. Okay. If I put a hole, means it does not include that number there. Okay. But it says greater than negative 3. So I will include everything on the right of negative 3. If it says less than negative 3, I will include everything on the left of the negative 3. So how will I show it's greater than negative 3? I will just put an arrow. Okay. I will just put an arrow on the right. Okay. I said arrow. It's not supposed to be just a line segment, but it is an arrow because it continuously goes to the right of negative 3. So it should be an arrow. Okay? Next, x is less than 4. X is less than 4 meaning 4 is not included in the graph. So it means I will just put a hole on 4. 4 is here. I'll put a hole there. And I will include everything on the left of 4. So I will just put an arrow on the left because it's less than. Okay, there. Next, I will have x is greater than or equal to 1. Now, it's equal to 1, but also include everything on the right of 1. So when I graph, it will be 1 is over here. Okay, I'll include, that's why I put a circle which is shaded. Okay, it is supposed to be shaded, so I will include that and everything on its right. I will include everything on the right. Next, x is less than or equal to -2. Again, there's an equal sign, so I will include -2. -2 here, I'll include that. Okay, that's why it's a shaded circle and everything on its left. I'll draw an arrow to the left. There. Next, let's try to do some examples about inequality. Example number 1. Solve 2x minus 5 is greater than or equal to 3 and show your answer on a number line. If I want to solve this, I have to add 5 to both sides. Then it will become 2x is greater than or equal to 8. Then I will divide both sides by 2. After dividing both sides by 2, it will become x is greater than or equal to 4. Thus, our answer here will be x is greater than or equal to 4. You cannot just say that your answer is 4. Okay? It should be a set of values, okay, that includes 4 and everything that is greater than that. Okay? I want to show that on a number line. I'll draw a number line like this and then find out where is 4. 4 is over here. I'll include 4, so I'll put a shaded circle, then everything on its right. So I'll draw an arrow to the right. Okay? Next, example number 2. Solve 7 minus 2x is less than 5 and show your answer on a number line. Okay? I'll take away first 7. Okay? If you take 7 from both sides, it will become -2x is less than -2. Now, recall what I've said a while ago. If I will divide both sides of the inequality by a negative number, then I have to reverse the sign or the inequality sign. Okay? So instead of writing less than, it will become greater than. Okay? So x is greater than 1. Okay? Why 1? Because -2 divided by -2 is +2. Okay? Next, we'll have to graph on the number line. Okay? X is greater than 1. So since x is greater than 1, I'm going to look for the 1 and put a hole on that because it's not included. So 1 is here, put a hole, and then everything on the right of 1. So I'll put an arrow to the right. Okay? Example number 3. Solve 3x minus 4 is less than or equal to 2 times the quantity of x minus 3 and show your answer on a number line. In order for me to solve this, I'm going to expand first this bracket. So 3x minus 4, okay, is less than now to 2x minus 6. Why 2x minus 6? 2 times x is 2x. 2 times -3 is -6. Now, I want to remove this 2x and bring it to the left side. 3x minus 2x will become x. And then -6 will be left on the right. Okay, so x minus 4 is less than or equal to -6. Now, I'll take away this -4, or so that I can remove that, I'll add 4 to both sides. If I add 4 to both sides, it will become x is less than or equal to negative 2. Okay, remember I did not multiply or divide the inequality by a negative number. That's why I did not reverse the inequality sign. So I have this as the solution. Okay, take note that x is equal to negative 2 and less than negative 2. So therefore, I will include negative 2. So instead of putting a hole on negative 2, I'll shade that hole. Okay, and include everything on the left. So I'll draw an arrow to the left. Example number 4. Okay, now let's go to a complex example. You will see now two inequality signs over here. Okay, when you read this inequality, you have to read this as coming from the center. 3x plus 1 is greater than 4. So you will see it's supposed to be less than, but you have to also read it from the perspective of 3x plus 1. Okay, 3x plus 1 first, you read is greater than 4. And 3x plus 1 is less than or equal to 16. And show your answer on a number line. So if I want to show this, okay, since there's no x value on the left and on the right, I can solve this equation as 1. Let's try to solve it as 1. Okay, I'm going to take away 1 from the center. If I'm going to take away 1, I'm going to subtract also 4 to 1. I'm going to subtract also 6 by 1. 16 by 1. Okay, 4 minus 1 is 3. 3x plus 1 minus 1 is 3x. 16 minus 1 is 15. I have that. Okay, now I want to remove this 3 beside x. Okay, if I want to remove the 3, I am going to divide both left, center, and right by 3. Okay, so if I divide, it will become 1. This 15 will become 5. So the solution of the equation or the inequality is x is greater than 1 but less than or equal to 5. Okay, so if I want to show this in my number line, I will only consider everything that is greater than 1 but less than or equal to 5. Okay, take note, x should only be greater than 1. You do not include 1, so you put a hole on 1. Okay, I'll put a hole on 1. Okay, and I will include 5. Okay, so it says everything that is greater than 1 but less than 5. I will not extend it going to the right and go straight. Okay, I will not do that. I will end to 5. So I will just have this. Okay, I will not also extend to the left because I need to end at 1. I need to satisfy the inequality that I have here. Okay, next. Example number 5, and this will be our last example. 2x plus 1 is greater than x, and 2x plus 1 is less than or equal to 7. Show your answer on a number line. Okay, in this case, I need to separate the two inequalities. Okay, and solve it separately also. 2x plus 1 is greater than x, or x is less than 2x plus 1. This will be our first inequality. The second inequality is 2x plus 1 is less than or equal to 7. Okay, let's do first the first inequality. Okay, I'll take 2x from both sides. If I take 2x from both sides, x minus 2x is negative x. Then 1 will be left on the right side. Okay, recall that if you multiply both sides by negative 1, the symbol will be reversed. So it means x is greater than negative 1. Next, I have 2x plus 1 is less than or equal to 7. Okay, I'll take 1 from both sides. If I take 1 from both sides, it will become 2x is less than or equal to 6. Okay? I'll divide both sides by 2. It will become x is less than or equal to 3. Okay? Now, if I want to show my answer on a number line, okay, I'll try to do some experiments and try to graph this one and graph this one. Okay, if I will graph this, it will become negative 1 with a whole. Why? Because it doesn't have any equal sign. And everything on the right. Okay, and x is less than or equal to 3 means I'll put 3 shaded and everything on the left. Okay, you will see that the common things that you will see now are from negative 1 common and 3, but please do not include negative 1. You will just keep it as a whole. Okay, and 3 will still be included. Okay, you will see that there's nothing in here. Okay, meaning I will only have x is greater than negative 1 but less than or equal to 3. Okay, meaning the graph should only be from negative 1 to 3, but negative 1 is not included. Okay, that ends our lesson about solving linear inequality. Thank you for watching. If you have learned something from watching this video, please don't forget to like and share to your friends, most especially those who are studying mathematics. And if you are new to this channel, please don't forget to like, subscribe, and click that bell button so that you will be updated with the new lessons that we are going to have here in our YouTube channel, Add Maths Plus Maths.